So a few years ago, we actually put out a survey, interviewed a few farmers and asked them what some of the biggest restrictions with the adoption of irrigation scheduling were. And usually it came back to the cost. They didn't find that it was beneficial cost. And the other one is, I mean, the remote access to some of this information. I mean, there's no, if you had to go to the field anyway to monitor some of this equipment, I was gonna take a soil auger with me and test it anyway, so part of our investigation over the last few years is to look at some of the newer technologies out there. Again, the four key aspects, I'm focusing now on the soil moisture content status. So now we look at sensor technology. So a sensor essentially is just a device that has the ability to detect a physical stimulus and transmit that response. The biggest advancements in sensor technology has caused a price decrease, but also the communications side of things has really ramped up the applicability of some of these sensors. So sensors tend to fall in two categories: in situ, which means in place or located within the field, and remote. So that's more of your drone type technology where it's non-contact with the soil and you're measuring from a distance. Just briefly about precision accuracy, in case you ever come upon this. Basically, accuracy is how close to the value. So how close to the actual value. So the more accurate a device is, the closer to the bullseye. Or precision is how closely those readings are clumped together. And as you get a more accurate, more precise device, you're going to see an increase in cost. But just so when you're speccing out some of these devices, you'll see these accuracy, precision values when you're purchasing them. Key is always calibrate your instruments. Always find either a secondary measurement or baseline measurement that will help you bring that sensor either back into what it's actually reading, or at least give you an idea of how far it's off all the time. Sensors tend to drift over periods of time. It's just normal wear and tear. So soil-based systems, like Gary had kind of mentioned, the tensiometer is one of the only ones that directly measures kind of the suction tension. Most other soil instruments measure what's called just dielectric constant. It's a conductivity / insulation. It's an electrical term to describe how fast or how easily a signal moves through the soil. The key here is, if you see air has a dielectric constant 1, water is 80. So we know that big range can be used to our advantage in that the more water within the soil is going to really drive those numbers one way or the other. So dry soil 3 to 5. So as we add water, we know that that value is going to move closer to that 80. So some examples, TDR. So TDRs have been around for quite a while. Basically, this is called a POGO. It's a small portable TDR sensor. So on this one there's four times, but usually it's 2 times. So a signal is transmitted along the tine, and the time it gets to get to the end of the tine and back is proportional to soil moisture content. The other 2 on this is actually a temperature sensor and a sensor that measures the electrical conductivity. The key here is that these tines must remain parallel. So if there's a bend in these, it's really going to throw off your measurement. This technology has been around for quite a long time. It's since the processing and the communication that came along that they started packaging them in nice units like this. So again, I use what's called a decagon for research. It's a high precision instrument, but it also comes with a high expense. This is a Stevens Pogo. These they're actually sold for the golf course community. Because it's portable, and also you're only really measuring, when you measure, you're only measuring the average soil moisture along the length of the tine. So really you're only measuring 2 inches down, but on a golf course where you're just concerned about the green and stuff, that's kind of where these are situated. These ones work off a Wi-Fi signal, so it reports right to your phone, uses the GPS in your phone to kind of give you a location. Newer company that's just come up in Canada, based on a Dutch